Welcome to qnawire.
In this problem, we simply need to find the densities by dividing mass with volume. We know that density is mass by volume, but we just need to do it with a consistent unit, with consistent units, so that we can compare them at the end. Now we'll go one by one. We know that for sample A, the mass, let's go with mass here and volume here. The mass is 8 grams and the volume is 1.67 into 10 power minus 6 meter cubed. Now we'll use kilograms for mass and meters for meter cube for volume as our base units. Now density would be mass by volume, and 8, a gram is 10 power minus 3 kilograms. And this is simply in meter cube, so we can simply use that, 10 power minus 6 meter cube, which turns out to be 4.79 into 10 power 3 kg per meter cubed. Now similarly for sample B, we know that the mass is 6 microgram, which is 6 into 10 power minus 6 gram. And we know that 1 gram is 10 power minus 3 kilogram. So that is 6 into 10 power minus 6 into 10 power minus 3 kilogram. And the volume is 9.38 into 10 power 6 micrometer cubed. We know that 1 micrometer is 10 power minus 6 meters, and hence this can be written as 9.38 into 10 power 6 into 10 power minus 6 meter whole cubed. Now density is mass by volume, and the mass is 6 into 10 power minus 9 kilogram divided by the volume is 9.38 into 10 power 6 into the 10 power minus 18 from here meter cubed, which turns out to be, if you plug it into a calculator, 0.64 into 10 cubed kilogram per meter cubed. Now for option C, the mass is 8 milligram, which is 8 into 10 power minus 3 gram, which is 8 into 10 power minus 6 kilogram. And the volume is 2.5 into 10 power minus 3 centimeter cubed. We know that 1 centimeter is 10 power minus 2 meters, and hence this can be written as 2.5 into 10 power minus 3 into 10 power minus 2 meter whole cubed. Now the mass would be 8 times 10 power minus 6 kilograms divided by the volume is 2.5 into 10 power minus 3 into 10 power minus 6 meter cubed, which turns out to be 3.2 into 10 cubed kilogram per meter cubed. Now for option D, the mass is 9 into 10 power minus 4 kilogram. We can directly use this, and the volume is 2.81 into 10 power 3 millimeter cubed, and each millimeter is 10 power minus 3 meters, so that is 2.81 into 10 power 3 into 10 power minus 3 whole meter whole cubed. Now the density is mass by volume. The mass is 9 into 10 power minus 4 kilogram. The volume is 2.81 into 10 cubed into 10 power minus 9 meter cubed, which turns out to be 0.32 into 10 cubed kg per meter cube. Now for option E, the mass is 9 into 10 power 4 nanograms. We know that 1 nanogram is 10 power minus 9 grams. So that's 9 into 10 power 4 into 10 power minus 9 grams, which is 9 into 10 power 4 into 10 power minus 9 into 10 power minus 3 kilograms. And the volume is 1.41 into 10 power minus 2 millimeter cubed. And we know that 1 millimeter is 10 power minus 3 meters, which gives us 1.41 into 10 power minus 2 into 10 power minus 3 meter whole cubed. Now, density is mass by volume. Our mass is 9 into 10 power 4 into 10 power minus 12 kg divided by our volume is 1.41 into 10 power minus 2 into 10 power minus 9 meter cubed, which turns out to be, if you plug it into a calculator, 6.38 into 10 cube kilogram per meter cubed. Now for option F, the mass is 6 into 10 power minus 2 milligram. You know that 1 milligram is 10 power minus 3 grams. That is 6 into 10 power minus 2 into 10 power minus 3 grams, and each gram is 10 power minus 3 kilograms. And the volume is 1.25 into 10 power 8 micrometer cubed. And 1 micrometer is 10 power minus 6 meters. So that's 1.25 into 10 power 8 into 10 power minus 6 meter whole cubed. Now density is mass by volume. Mass is 6 into 10 power minus 8 kilogram, and volume is 1.25 into 10 power 8 into 10 power minus 18 meter cubed, which turns out to be 0.48 into 10 cubed kilogram per meter cubed. Now that these are in the same units, we can simply compare the numbers to write them from smallest to the largest. Obviously, the smallest is D, and the next smallest is F, and then it's B, and then C, and then A and D. This is the increase. I'm sorry, E. The last one is E. This is the increasing order of densities, with D being the least dense and E being the most dense.